Hi, this is Margaret Flagg, and I'm here to present the TEAM01 final presentation of the Ventilator Weaning Recommendation System for CS6440 Fall of 2020. Our TA mentor is Raj Bansia. The goals of our system were to create a ventilator weaning recommendation system to help clinicians identify when a patient was ready to be weaned. The requirements was to create a system that indicated when a patient was at low risk for weaning. Our team roles and responsibilities, we have Stephen Campbell as our project manager and clinical researcher. He coordinated the team meetings and assignments. He did clinical research for ventilator weaning and development of clinical data simulation. Margaret Flagg updated the Gantt charts, did QA, wrote the use manual, and helped with the final presentation, as well as other administrative tasks. Carl Franklin did front-end design and development. Micah Halter did back-end API design and development. Bhupinder Hayer, he was the lead for front-end design and development, and Joseph Rayner did back-end development in the CI/CD pipeline. This is our Gantt chart. We had a 12-week project outline. Week 1, we did team formation. Week 2 was our project introduction. Week 3 and 4, we performed clinical research, designed the layouts for the front end, designed the modules for the back end. Week 5, 6, and 7, we created a data strategy, created the front end screens, and created the back end modules. Week 8 and 9, we did integration testing of the front end and back end. Week 10, we prepared for the presentation, and this week we are getting ready to submit our presentation. And last but not least, we will do the evaluations of our team member and mentor. Some of the future plans and opportunities for the system are to do graphing. It would be great if we could graph the vitals of the patients so the clinicians could see if they were improving rapidly or not. It would also be good to use CDS hooks, which would help us to determine if the clinicians were actually taking action when they needed to and the outcome of the breath test. In addition, we would continue with medication research as that continues to change. That may help people to wean from the ventilator quicker. In addition, we have measurement research. We are currently using a formula to calculate the risk score. If some of these vitals maybe became less important, we would remove them. If some of the vitals became more important, we would add them. So we would continually be looking at that measurement to determine when it would be best to wean the person. And last but not least, COVID-19 research is ever changing, and so we would need to be on top of that to see if there were better methods or better medications to help wean those people. And now I will turn it over to Micah for further research on the ventilator weaning system.
We spent the first sprint of the project and the first couple weeks conducting critical research to better understand the problem of predicting when patients are ready to be weaned off of ventilation. The majority of our research was spent reading UpToDate, an industry-standard clinical decision support resource where we found information on how ventilator weaning decisions were made in general. We also found a few recently published papers regarding ventilator weaning requirements in patients of the novel coronavirus SARS-CoV-2 or COVID-19 to compare between that specific case and the more general cases. COVID-19 is particularly detrimental to the respiratory system and requires some slightly more strict criteria be met before patients can expect to be successfully weaned off. And then finally, we met with and interviewed a registered respiratory therapist with Piedmont Atlanta, Andrea De Rosette, who was able to confirm the information that we had found during our research, as well as clarify some. With the research finalized, we constructed 2 sets of risk factors we wanted to take into consideration in our final application while evaluating ventilator weaning risk. One set of risks were for the more general non-COVID cases, as well as a set of requirements specific to COVID patients. So this is a table of our risk factors and their criteria for the generic cases of non-COVID patients. In the table, if any of the criteria is met, then that is an indication that the patient is at risk and is not to be weaned off ventilation because it may not be successful and be more detrimental to their health. When evaluating these risk criteria to a risk score, we simply add 1 to the score every time the criteria is met for a risk factor, and the final score is a value of between 0 and 8. Here, the patients with a score of 0 are ready to be weaned off immediately, and the patients with a high score are more at risk and should not be weaned. Our research revealed 8 main risk factors when deciding whether or not a patient should be weaned off of ventilation. First, the ratio of arterial oxygen to the fraction of inspired oxygen and oxyhemoglobin saturation ensures that the patient is getting adequate enough oxygenation and that is appropriate for weaning. Arterial pH helps identify oxygenation of blood, as well as blood pressure to identify patient stability. Hemoglobin levels indicate anemia, which reduces oxygen carrying capacity and can cause a risk for patients to be weaned off ventilation. The rapid shallow breathing index measures how much a patient can tolerate independent breathing and is a major indicator of ventilator weaning readiness. Other factors such as dopamine and body temperature help indicate overall health of the patient and whether or not if they're in need for dopamine or have a fever, that could indicate that they are not healthy enough to be weaned off of ventilation just quite yet. So this next slide looks very similar. It's our risk factors for COVID-specific patients. The risk indicators are the same as described previously, but the differences can be found in the criteria. The criteria for the arterial oxygen tension ratio and the arterial pH are more strict than in the general cases. This is due to the severity of respiratory issues caused by COVID and the need to be more careful when it comes to attempting to wean patients off of the ventilation too early. With these risk scores criteria set, we have a rigorous definition of when a patient is ready to be weaned off and can focus on implementing a user interface for calculating these risk scores and presenting the results clearly and concisely to doctors, nurses, and medical professionals. The next slide will go into our application demonstration.
Hello, my name is Carl Franklin, and this is a demo of the Ventilator Weaning Recommendation System. The URL to access the application is highlighted. It is also available in the documentation. What you see here is the landing page for the application, and it consists of 2 sections, the statistics and the patient list. The statistics shows the total number of patients on the ventilator, the average days that they're on the ventilator, the total number of patients that are ready to be weaned, and those that are at high risk. The patient list section lists all of the patients that are on the ventilator, along with if they are a COVID patient or not, and their risk score. The ventilator risk score is based on a standard clinical criteria for weaning recommendation that factors in patient vitals, the lab results, and their medications. One of the things we found during our production run was there was quite a bit of latency in fetching the data from FHIR for all of these patients. So our backend lead was able to implement a fix to improve the response times through a H2 in-memory database that will house the data from FHIR, and the rendering for this screen will fetch the data from that database. Now, if you want the most current data from FHIR, there is a green button on the top right corner of the screen that says refresh data from FHIR. Clicking on this button will get us the most current data. So let's go ahead and do that. There's a pop-up that says the data is being fetched. Let's click on OK. Now refreshing the screen will get us the most current information. By selecting one of these rows, we will be able to look into patient information. So let's go ahead and do that. I'm going to select that this patient, and this is the patient detail screen, which consists of the patient information, their vitals, their medication. There is a risk score circle which is color coded. If the risk score is 0, that means it's green. If the risk score is less than or equal to 3, that'll be yellow, and if it is greater than 3, it's going to be red. There is also a line graph at the bottom of the ventilator risk score across time. On the top right corner, there are 3 buttons for simulation. Clicking on these buttons will insert values into the vitals so as to effect a change in the risk score. The first button, New Random Vitals, will insert random values into these vitals. The second button, called Improve All Vitals, will insert values into these vitals so as to improve the risk score. So in this case, the risk score will trend towards 0. Decline all vitals will essentially do the opposite. Now, in the interest of time, let's click on one of these buttons. I'm going to click on Improve All Vitals. There's a pop-up that says the new vitals have been created. It asks us to wait for 60 seconds so as to ensure that all of the updates have occurred in the file server before initiating a new simulation. Let's click on OK. Now refreshing the screen. Now, as you can see, the vitals have been updated and the risk score is now 0. Clicking on Dashboard takes us back to the main landing page. That concludes the demo. Thank you for your attention.